right, so I'm Jerry Olla, CWNE number 238, and I'm going to be talking to you guys about the WLAN Pi project. I'm sure you guys in the back of the room over here can see this okay, right? You guys see this all right? Pretty small little guy, right? So you can see some pictures of it up on the screen here. We'll go through a few more close-ups so you can get a better idea if you haven't seen this in person. But yeah, this has actually been around for a little while now. We'll talk a little bit about the history. Pretty much what you see on the slide here is going to be the agenda for this talk and what we're going to kind of go through. And really the focus here is, what can this little guy do, especially as a wireless professional. So yeah, let's talk about that a little bit. First, WLAN Pi. Why do we call it a WLAN Pi? Well, actually about a year ago, right about a year ago, sitting in this room, we brought this kind of guy to life in this community with the previous gen, we'll call it the black version of this. This is the silver, basically the same thing. And we were using it as an HyperF tester and trying to come up with the name of, what do we kind of dub this thing so people know what we're talking about, so we have some kind of commonality. And of course, as all good names come, was the domain available? So that's why we got it, because the domain was available. So WLANPi.com exists. So yes, if you want to find more information, we'll talk about that. WLANPi.com is where that's at. So yeah, the WLAN Pi project, this is a portable tool. Obviously, as you can see, it's easy to throw in a pocket, in your bag, whatever it is, and it's very versatile. So this is really the key elements here that make this guy up. So portable, versatile, and really the focus here is anything we do with this guy is got to be ideal for wireless professionals and the majority of the tasks and stuff that we're doing. So that's really the focus around this project. And it's very community driven. This was kind of an idea that I first brought up with Keith several years back. Many of you probably went through the maker session, and it's kind of just grown from there. So yeah, let's kind of take a trip down memory lane. So in 2016, this was the Odroid C2. How many of you guys have one of these laying around, maybe collecting dust, hopefully getting some use? But yeah, this was kind of the first crack at this, and the biggest thing that this thing had at the time, especially back in 2016, was it had a gigabit Ethernet port on there, and we could power this little box with a battery. So those were two big things to creating that portable, kind of versatile solution. So this was just basically an HyperF box, and that's what the whole thing kind of stemmed from. In 2017 then, we kicked this off a little bit further, and one of the big challenges that we found in the previous Gen 1, or really it's the same board, but one of the big things that were lacking was when you plug this thing into a network, we had no visibility to what IP address this thing got. It would receive an IP address, but then you had to go to like a DNS server or something to figure out, okay, what IP address did this thing get assigned, and kind of reverse that. We tried all sorts of things. I did initially like an email script. It would actually send an email of what its IP was, but ultimately we just wanted the thing to tell us what its IP was. So we put this screen on there, and we basically use it to print the IP address on. You could do some other stuff with it, but its main purpose was to show the IP. So then, yeah, 2018, last year, this is that actual, original WLAN Pi that we used last year at the WLPC conference, and that's what really kind of kicked this thing off even further, and that's where we dubbed it the WLAN Pi. But yeah, you can see it's a much smaller form factor. This is this year's edition of that. Very similar to last year. Actually, the board inside here is the identical Neo 2 board that we'll talk about. And again, still gigabit Ethernet port on here, plus other goodies that we'll talk about. But yeah, the cool thing on here, we've got an OLED display, so we can still print the IP address and get this thing connected to a network and do all sorts of fun things with it. All right, so that's kind of the history of where this thing came from. Now let's talk a little bit about the hardware that's in here. So this is the NanoPi Neo 2 board. So there's really two boards in here. The lower board, the main board, really your single board computer in here is the Neo 2. And for kind of reference, I'm sure everybody in here is familiar with the Raspberry Pi. That's kind of the more popular, bigger brother, we'll call it. And you can see, Raspberry Pi, another great single board computer out there with a lot of support from other communities. But what we found was the Nano Pi, given its lower power requirements, and just the main thing, it checked all the boxes that we needed in a smaller form factor. So yeah, true gigabit. The interesting thing is even though the Nano Pi, the Neo 2, is much smaller, really less than half the size of a Raspberry Pi, we actually get better network throughput out of this guy than out of the Raspberry Pi. Both do technically have gigabit Ethernet ports, unlike the Raspberry Pi 3 Model B. But if you actually do network throughput testing on there, I think it taps out somewhere around like 600 megabits per second or something like that. So just the way the architecture is written, that's not really what it's built for. This is a little more geared for that. But yeah, you can see the power consumption there. That does come into a bigger factor. You'd think, 200 milliwatts versus 350 milliwatts isn't a big deal. But when we've got USB ports on here, we want to start plugging in Wi-Fi adapters and transmitting frames and those kind of things. We want a nice idle low power on this guy, so we have a nice low power to start from, because then we can do a lot more cool stuff when we start off at that lower kind of power point. So yeah, wireless adapters. This has been a thorn in my side through this project, as anybody that's worked with Linux before. Getting Wi-Fi adapters to work with Linux and the drivers and the support on that is pretty minimal, so I've spent a lot of hours, and I'm happy to say that we have a good and a pretty cool solution now for that, and there's been some pretty cool movement in that space with Linux drivers. So yeah, we now have the Realtek, the 8812 AUs and 8814 AU Wi-Fi chipsets working reliably with it. Not perfect, but we can use them to do some pretty cool stuff for monitor mode as well as packet injection. You can see kind of in the table here, there's actually 55 different types of adapters out there that use that 8812 AU. It's been around since 2012, so this thing's finally getting to the point where we've got some good stable drivers. It's a 2x2, 2 spatial stream, 802.11ac chip in there. I'm sure if you guys have any kind of adapters rolling around in your bag, one of them at least has this chipset on it. So that's the other nice thing, is you probably already have plenty of these laying around in a drawer and things like that. I remember getting one of the Edimax ones probably, I don't know what it was, 3 years ago or something at WLPC. That's the same chipset, so this is not anything brand new. That's the little flip-up antenna on there, that white one. That's that same Realtek chipset in there. But yeah, there's the newer one now, the 8814. That is actually a 4x4 3 spatial stream, and that also works, so we can do monitor mode with that. So kind of cool to have a nice portable solution like this that you can pop in a USB adapter and be able to capture up to 3 spatial streams. Definitely fewer devices than that. That's a newer one, but up to 13 different devices out there now that are being sold with that chipset in there. All right, so that's the hardware. Let's talk about where do we use this thing? What's the usage? There's a lot of different places that we can see where you could plug this guy in. It started out as just being really this HyperF endpoint, like I mentioned, where you plug it into your wired infrastructure, typically somewhere at the head end, and then you're measuring the throughput as you're maybe walking around performing a survey, or if you got complaints in a certain area of the building, we can go and test that and have that closed loop. Instead of relying on speedtest.net, we can use this as our in-house speedtest.net server and be able to just test the throughput of the closed loop, right, the internal network. And then also maybe do a speedtest.net and compare the difference, right, and be able to quickly tell, is this a local issue or is this a WAN issue? So local network endpoint, as I mentioned, you drop the WLAN Pi, it's kind of your little drop box on the network, you plug it in a conference room at the head end of the network, and now you can connect your laptop or phone wirelessly and be able to communicate with it to do some performance testing. Another use case, this is the more recent one that has really, I'd say, kind of accelerated some things with what we can do with this guy and really opened up a new world of possibilities beyond just an HyperF tester. So being able to do Ethernet over USB kind of frees us from the whole, having to carry around maybe an Ethernet cable to connect this to it. and gives us a whole new list of options that we can do with this. So I can take a single USB cable, plug the micro USB in here, plug this into my computer, and now not only is my computer's USB port powering the WLAN Pi, but that's also creating an Ethernet connection, a virtual Ethernet connection between the WLAN Pi and my laptop, whether it's Windows, Mac. We can now communicate with that over that. So we can SSH into it. It's got a web server running on it. We can access that web server and that web menu to be able to do a bunch of different tasks. Plug in a wireless adapter, and you guys can connect the dots there. We've got a wireless adapter plugged in that supports monitor mode and packet injection, and that's the whole setup that we need for that kind of direct connectivity. We could stream those packets back to our machine over that USB connection, straight into Wireshark. A lot of options there. All right, so remote connectivity, this is the other option that we can do with this. So similar to plugging this into the network, but now we can access this thing remotely as well. So I've got one of these running at my house currently. We'll see if we can get the internet stable enough here, and I'll do a demo and show you how I can, being hundreds of miles away, be able to access that WLAN Pi and find out information about the RF environment in my house. So doing it as like a remote sensor type thing. So those are 3 common usage scenarios. Other usage scenarios, since we have now 2 USB ports on the new silver versions, started to explore options of, hey, what if we put a second wireless adapter in here? Connect one wireless adapter to the wireless network, and then the other adapter is sitting in a monitor mode, listening and scanning, those kinds of things. And now you have just, maybe a battery-powered drop box that you don't even have to have Ethernet connectivity to it. So let's talk about the software side. So this is running Linux. We found Armbian to be the best as far as a nice lightweight, it's a Debian distro if you're familiar with Debian distros. And you pretty much have the full power of Debian at your fingertips on here in a tiny battery. Literally I have a quad core computer plugged into my USB port being powered off my USB port that is quad core Linux. So in the past maybe you fire up a VM or something like that. Now we have this hardware platform that we can use to do all those kinds of things. So this is my my modern day mixtape here is kind of the way I thought of it as I was kind of thinking through all the different tools and stuff like that we've baked into here. So if anybody created mixtapes back in the day, you find all your favorite artists and you compile them together and maybe give it out to your friends to listen to, that kind of thing. So yeah, think of the WLAN Pi image that we are distributing with this is a bunch of friends getting together, maybe creating some tools, using different open source tools that are available. And we've got features from the, some of these artists that you may be familiar with and recognize. If you're not following these guys on Twitter, I would highly recommend it because they're a lot smarter than me and have contributed a lot of great work to this project and different Python scripts and just helping getting some of this stuff hosted and out there for you guys to be able to consume. All right, so let's go through some of my favorite tools on here. We'll go through the hit list and yeah, talk about some of these. So one of the things that was that we set out to do was, initially this was HyperF. HyperF is, the industry standard for network performance testing. However, it can be difficult, especially nowadays with mobile devices and things like that, to try and do, okay, I want to know what my iPhone's throughput is on this network. Well, all these devices, for the most part, have a browser and they support HTML5. So we set out to find an HTML5 based throughput testing, similar to how speedtest.net does it, but we wanted to do it all locally without going out to the cloud or anything like that. So put a web server on here, found some open source code to be able to do an HTML5 based speed test, and this is what we ended up with. It's not beautiful. I'm not a web developer. If anybody in here does web programming and developing, I'd love to talk to you and if that's a way you could contribute, because if you looked at the code behind this, you'd probably not be too impressed, but it works. So yeah, it was more proof of concept, and it's actually proven to be pretty useful. So we put a couple different speed tests through the web side. You have the standard kind of graphing or the gauge speed test here, and then we also have the speed graph. Speed graph is kind of cool because it graphs it over time. So you do a test for a period of time and you're seeing that actual graphed output. So you can see, are things running flat or is it going fast, slow, fast, slow? And you can test both directions, right? Download and upload. And then we do have HyperF. So HyperF, all the perfs are on here. You've got HyperF 2, HyperF 3, you've got ePerf. If you're not familiar with ePerf, that's Ekahau's kind of custom built version of, based off of the HyperF 3 protocol. But that's some screenshots out of Ekahau there where we could do throughput testing as part of your passive survey. You could do what we call an active survey and be hitting this box, doing your throughput test and getting those measurements that you can then record and then display post-survey. Another tool that's on here, anybody familiar with Ruckus SpeedFlex? Hopefully a few of you guys are, yeah? Pretty cool tool actually. If you haven't played around with it, I would recommend it. So one, they have mobile apps, both Android and iOS. This guy is running the Zap SpeedFlex server on here. So just like on all your Ruckus gear, which is one of the nice advantages of Ruckus gear, is all of their gear are running this Zap server instance. So you can test the throughput to any device on there. Well, what if you don't have Ruckus gear, or what if you do have Ruckus gear, but you want to test to something that's not a Ruckus endpoint? Well, this could fill that need, right? The other thing about Zap, if you guys follow Revolution Wi-Fi's blog, he's done some really cool stuff with Zap. If you search on his blog, through the Commandline stuff, there's some really powerful things where you can get all sorts of percentiles and things like that, and he's done some really cool work of graphing that out and actually being able to see what's happening over time, right? All right, so let's talk about some other pretty cool tools on here. So this one is been around for a long time in a very different sense than it is today. So Kmet, this thing used to be a command line tool, and as you can see in the screenshot, if you haven't taken a look at it, it's pretty impressive. They've done some really good work on the web side of things now and brought it out of the command line interface into a pretty awesome web. And not only does it do Wi-Fi, it supports a ton of other wireless protocols, and you can aggregate it all into a single pane of glass here, and you can see all the Bluetooth devices, all the, water meters, that have wireless connectivity, and all the information about these things and aggregate it into a single pane of glass. Anybody seen the Wi-Fi cactus? That thing's been making its rounds for a while now. It's showing up at a few security events and stuff. That's what he's using. He's using Kmet to do all that, to aggregate all that data together from all these different radios into a single pane of glass. So it supports multiple data sources. And then you can sift through it all, and you can do all sorts of APIs and stuff with it to do alerts and create PCAPs and all that stuff based on those. Another one of my favorites, actually Panos, he's here, I saw him. He's the one that originally introduced me to this one. Really cool tool. This one is command line, but one of the coolest command line tools that I've played with. This does packet analysis and really it's focused around packet statistics. When I was studying for my CWAP exam, Panos introduced me to this right around the same time, and this was blew my mind as I was reading through the CWAP study guide and then learning about different frames and data rates and how things communicate, and I'd fire this thing up and be able to see that in real time, happening and actually really connect the dots. So this was awesome for me. We can measure things like retries, those kind of things. I will preference that it does have one big limitation, unfortunately. It hasn't been updated too heavily in a while, and one of the big things it's lacking is the statistical analysis of 802.11ac frames, the newer MCS rates and those kind of things. So still a great learning tool, and it'll work great on 2.4 and N networks, but AC is where it starts to break down, at least on the statistical piece of it, which is really the coolest part about it. Scapee, this is a new one to me, and this one has been really kind of kicking my butt as I've been preparing for this deep dive session that we're going to be doing tonight or starting tonight, but I've been learning just the power that it has. So Scapee is a Python library, and it does all sorts of cool stuff with Wi-Fi and the Wi-Fi protocol, of being able to decode as well as to inject and be able to create your own build your own frames and transmit them. So it opens up a whole, other kind of world of possibilities of, okay, we can script all sorts of cool stuff, either for, as you can see here, this was just a really basic packet analyzer that I created. We're actually going to create this in the deep dive class tonight. A couple other tools on the analysis side, you've got TCP Dump. That's another one that's been around for a while. Cool thing about TCP Dump, I mean, you run TCP Dump and you just see a wall of text, not very useful. But we can pipe that stuff and stream that to different places. So one of the things Wi-Fi Nigel has done is created the WLAN Pi Shark script that allows us to take all that great information that TCP Dump can capture and be able to stream that directly into Wireshark. That could be locally, like we've got our WLAN Pi plugged into our computer here. That could be over the cloud, and you could be doing that, receiving that remotely and analyzing a network across the world. Another cool one, see a few Mac users out here, Wi-Fi Explorer Pro. Hopefully if you've got a Mac, you've got Wi-Fi Explorer Pro. One of the things that Adrian just announced right before WLPC is some kind of added support. We've had the Wi-Fi Explorer sensor on the WLAN Pi image for a while now, but now he's actually made it even easier on the Wi-Fi Explorer Pro side, where it'll actually detect that the WLAN Pi is plugged into your computer, and it'll show up in the list of different scanning modes that you can choose, and you can actually choose this as your scanning adapter. One benefit of that, even with this being plugged in locally, is if you're not aware, if you leave that scanning and it's using your internal adapter, it kind of bogs your Wi-Fi connection down, right? Because it's constantly going off channel and doing those scans. Where with this, we could actually leave this connected and have this thing continuously scan while I keep my Wi-Fi untouched, right? So there's some benefits there. The other side of it is the remote piece of it, where we can take this thing off and analyze a network again across the world using that remote connection. I think this last tool I want to talk about is the Aircrack NG suite. This is another one that's been around for a long time. A lot of different command line tools, but we built the Aircrack NG suite in there. One, it just gives us a lot of power and capability over the adapter themselves, and now Aircrack does fully support this chipset that I mentioned before. So all those tools are accessible to us as well for both monitoring and injection. All right, so that's the software, and that was really the bulk of what I wanted to talk about today. But since we've got some time, let's talk about a few other kind of cool things that we've been, some new things along those. So clients.michaelbano.com, this thing's been around for a while. Hopefully everybody in the room has this thing bookmarked and is well familiar with it. If you're not, go do that now. This is the best database out there of client capabilities. The challenge is how do we get these client capabilities? Anybody that's contributed, how many of you guys have contributed to this database? Yeah, not a ton, right? But I'm glad to see, maybe a dozen or so of you guys in the room. How easy is that to capture that information and share that? Is that pretty straightforward? Depends on, if that's your line of work. Let's take a look here, and I pulled up the instructions for those of you that haven't done this before. Mike wrote this brief. If you can't see that on the top here, he wrote a brief 3-step process. You guys want to take a look at step 1 here. This is step 1. Keep going. Step 1. There you go, step 2. Step 1 is a little bit of a lengthy process, and there's a few variables in there and things to consider and those kinds of things. So what we aim to do with the WLAN Pi is figure out a way to simplify step 1, since that's kind of the barrier to entry here of why most people don't even bother with it, because they look at step 1 and they're like, that's too many steps in step 1. So what we did was, let's switch back over here. Working with Wi-Fi Nigel, we were able to figure out, okay, so what the whole thing with clients.Michael Bano is in that step 1 that we just went over really quickly there is we need to capture the association request frame, the client association request frame that the client sends to the AP when it connects. What I learned is, sounds pretty easy, right? Just do a packet capture and listen for an association request. The problem is there's all sorts of, it depends in there. And We're looking to get to that step, the fifth step in the process of a client associating to an AP. Client sends a probe request. We have to have something send a probe response. Client sends an authentication sequence 1, and then authentication open sequence 2, and then finally the client can send its association request. And we're looking just for that frame. So there's a lot of steps back and forth there to get to that point. What we did was created in the WLAN Pi, or I shouldn't even really say we, because this was 90% Wi-Fi Nigel. He created this Python script using scapee that will send out fake beacons, create essentially a fake access point, and not just any fake access point. It is creating a fake access point with all the capabilities, all the boxes checked. Why is that important? Well, if we don't tell the client the AP has the maximum capabilities possible, we don't know for sure the client is going to respond with what its maximum capabilities are. If the AP says, I only support 2 spatial streams, the client is going to respond back and say, even if it supports 3, it's going to say, oh, I support 2 spatial streams as well. It'll never say that it supports more than what the AP is. So that was important. So we had to make sure, one, if you're using an infrastructure, an enterprise AP, trying to get it to do that, you have to have all those boxes checked. That could be a pain right there. So yeah, what we did was we created this access point here. See if we can make this big enough so you guys can see what's going on here. Yeah, let's take a look at this fake access point that we're sending out. Notice anything interesting there? Fast transition is enabled. Generation 6. Streams. That's being transmitted from this. So we're able to, with scapee, like I said, craft or forge our own frames, and we can send those out, and now we can guarantee that the client is always going to respond with its actual maximum capabilities. So what that looks like is we get a report when the client tries to connect to that fake access point that we create. We get a report that looks like this, and it's going to check for all sorts of useful information. Actually, that clients.Mike Albano website, we really just mirrored what Mike was stripping out of there because we found that was all the useful information. And now we can see things like, does the client support these amendments, yes or no? How many spatial streams does the client support? Does it support single user beamforming, multi-user beamforming? What's its maximum transmit power? What channels in the 5 gigahertz range does it support? And we not only spit that out in the terminal here, but then we also go ahead and put that into our web server. So now I'm accessing the WLAN Pi here. I've got my profiler directory, and we can see that same report spit out here in a text file that I can now download and save. But also, we create that association request frame and save that as a PCAP. So now getting that over to Mike, we save our PCAP, and I go back over to his wonderful instructions here. I can skip all the way down to step 2 because I have my PCAP easily now, and now it makes it much easier for us to get that information over to Mike, right? So now we can add that to the database. Said community projects. This is we see these pain points and try and figure out ways to address those. All right, so let's go ahead and flip back to this here, and we've got a couple more things I want to talk about, and get this back into full screen here. There we go. Okay, so that's the what's new. So if you want to get involved, more information at WLANPi.com. As I mentioned, check that out. You can get the downloads, all that kind of stuff there. There's videos on how to build your own if you want to, actually order the parts yourself and build them. Keith's already got a team of people and assembling these things around the clock and selling them pre-assembled for you, pre-imaged. So yeah, if you're not that adventurous on that side of things, you can do that and get those off the Wireless LAN Pro store. But yeah, if you want to contribute, if you got some ideas, definitely want to hear them. Probably easiest way, obviously Twitter is a great place to start. A couple other ways that you can also get involved. Go back into present here. A couple other ways that you can get involved, Slack. So this has already been brought up, I know, in some other presentations. If you're not on Wi-Fi Pro's Slack, definitely get on there. May or Sam can help you out with getting an invite. So tweet those guys, and I'm sure they'd be happy to get you invited. We do have a WLAN Pi channel then that we've been doing a lot of chats in. Also, we have a GitHub account now, thanks to Scott setting that up and learning me on GitHub. Still a GitHub kind of noob, but it's been a great way to kind of communicate releases and have that change log and everything for you guys to be able to find and access. All right, so we got a few seconds left here. So what's next? This was just some ideas that I came up with off the top of my head just to get the kind of gears turning, but obviously this is all community driven, so we can go whatever direction the community, where the needs are, right? As I already mentioned, I'd love to see some enhancements to the web UI. It's pretty basic right now, and it's not an area that I have any kind of skills in. This is me Googling for hours and putting a very basic menu system together just to get something there. This was a cool recent discovery. iPad Pros now, the latest generation, if you're not aware, have a USB-C port on them. USB-C provides some pretty decent power out of the USB port and is enough to power the WLAN Pi with an adapter and create that virtual Ethernet connection. So again, we discover these things and hey, the gears start turning, a whole new world of possibilities. We could see some apps being written. Now we can unlock that piece of the iPad. Still can't leverage really the internal adapter for at least analysis, but what we were doing here was actually packet analysis using that Horst tool that we were talking about before, all being done natively on the iPad. This is, doing that virtual connection is the only thing that's happening there off the iPad. Also, this was another cool thing that happened just before WLPC here. Ryan tweeted out from MetaGeek, IPA support now working on a build, and I believe he's got a beta of it now. And I don't know if you've got a link you want to tweet out there or direct people to. But yeah, if you've got IPA and you've got a WLAN Pi, this could be a remote source for your IPA to get those packets into IPA. Other things in the future, looking at other hardware platforms, always keeping an eye on those. There's some things that I would like to see on here, one of those being USB-C. There's now this is the Neo 2. They have a Neo 4 out there now. It's not as, polished. We don't have the nice case and OLED display and all that kind of stuff for it yet, but this is one I've been keeping a close eye on. Mainly because of the USB-C, but also it does support some other cool things with it has a PCI bus on it, which could support things like a 10 gig Ethernet connection on there if we need to do more, more throughput testing or faster throughput testing on it. So yeah, that's it.